Meet Picasso. It stands for Perceptive and Adaptive Soft Wearable Robot. It's not an arm brace. It's not something out of Iron Man. It is something called a wearable exoskeleton, and it is the brainchild of City College robotics specialist Hao Su.
Our modular upper limb exoskeleton is the most lightweight powered wearable robot in the world because my lab developed the most lightweight motor and also the most lightweight robot.
Hao Su and his team were awarded a $2.78 million grant from the National Science Fund to develop Picasso. Now, most of the time, the word exoskeleton is associated with the hard external covering that gives insects their structure. But in Hao Su's field, a powered exoskeleton is a wearable, mobile machine. And his is a pioneering project in the burgeoning field of soft robotics.
Soft robotics is an emerging research field that we use soft materials to create robots. Conventionally, people use rigid materials like metal to construct robotic systems. The new approach is based on soft materials like rubber, fabric, those kind of soft materials to make robots.
So what can this robot be used for, and who is supposed to use it?
It can help people with disabilities, both for upper limb disability and also for people with lower limb disabilities, because the robot can generate mechanical forces to work in concert with human being. And it can also be used to augment human capability, like soldiers, workers, to reduce musculoskeletal injuries for people, for able-bodied population.
According to Hao Su, the robot can generate 30 to 40% of a human's torque. So for instance, if you suffered a stroke, Picasso can supply significant assists to compensate for muscle weakness. Or if you're an able-bodied laborer, well, that's all the less energy you have to expend to get a job done. And more remarkable is just how intuitive it is to use. No buttons, no joysticks here.
So how does the robot interact with the human's intention? How does it know what the person wants to do?
So essentially, we come up with a very clever idea that can detect human intention. It's based on basically the person can wear a small camera on the body. Let's say if you intend to grab a mug, and the robot can detect this kind of like intention, the basic movement. Even you cannot, because of disability.
And even with all this pioneering tech, it actually costs 85% less than conventional assistive robotics, because it uses less expensive, softer materials than metals. And economic implications like that are indeed a major component of the project.
One key goal of this project is we want to understand the economic impact for people with disabilities to wear this exoskeleton, both from the user's perspective and also from the company's perspective. From the company's perspective, we want to understand if the robot can really bring benefit to the employees and to enhance productivity using this kind of like a smart assistive device.
Professor Hao Su's next steps? Refining his team's designs and software and having Picasso widely available in 2021. For Simply Science, I'm Ari Goldberg.